Hello everyone, welcome back to the channel. This video is a part of series of videos where we're discussing about various concepts related to modeling, code development and many more. If you have not yet watched the previous videos and you would like to know what are the various concepts which we have discussed, you can check it out here. The current video we will be discussing about a type of neural network which we'll be further developing in this series of videos to see how we can write a code for the same and also do a hydrological model. So let's directly get into the concept about this model. As you can see here, this is the basic outline about the type of elements which are involved in the Narx neural network. So let's just try to break down each element of the neural network and see what each element implies and how each element influences the outcome of the model. So initially we will try to see what is the abbreviation of Narx first. If we see Narx, N implies nonlinear, autoregressive with exogenous inputs. So the basic definition or an abbreviation of Narx is nonlinear, autoregressive with exogenous inputs. So now let's try to break down this abbreviation furthermore. What does nonlinear mean? Nonlinear represents the elements which have sudden changes in it and they do not follow any logical way. So just to put it in a simplified manner, it represents that linear elements tend to form a straight line, whereas the nonlinear elements do not form a straight line, as you can see in the image here. So this is what nonlinear in the term Narx mean. So let's get into what does autoregression means. Autoregression takes into account the past values and determines how these past values are influencing our present values. In a simpler term, if we say the autoregression allows the model to see into the past and try to predict future that might be either the current values or the next day values. What does exogenous means? We've already seen about what is nonlinear and what is autoregressive. So let's see what does exogenous means. The general term exogenous means the external source or external agents. Whereas in the terms of modeling, we can say these are the external elements which are giving into the model. So this is what the basic definition of the Narx neural networks mean. So once we have known what the definition of Narx neural network is, let's get into the basic structure of Narx neural network and what each element in the structure means. So if we see here, this is the basic structure of Narx neural network and these are the various elements which are present in Narx neural network. The elements are input delays, feedback delays, weights, bias, hidden layers and output layer. So let's just break down each element and see what does it do in the structure. First we'll be talking about input and feedback delays. The input delays are the elements which decide what data is taken into the structure of the neural network to be able to give us the output which we require. It decides what elements are used for predicting the outcomes. So in the name itself, it includes input delay and feedback delay. Input represents the input which we are getting. Feedback represents what the model is trying to bring back into the network to give a better output. So input delay. The delay represents we can, in the model settings, while developing a model, we can give the model a input delay value which represents that, let's say we want the model to give us the current value based upon yesterday's value. So we can keep the input delay as 1. So it takes yesterday's values and gives us today's values. This is what the input delay does. It tries to tell the model that see these values in the past and give us the current or future value. So that is what the next statement represents. The input delay is I, like ith term, like yesterday, day before yesterday, or the before day. So it takes the ith term and starts from there to develop the data set ready. It automatically generates the required data set based upon the input delays which we give without modifying anything in the data. So this is what the input delay does. Similar to input delay, feedback delay also does the same procedure where it brings back the results which we get during the run to try to correct it using a training function or a learning function. So that is how a feedback delay also works. So now let's get into the next element called as hidden layers. So in any neural network which we can think of or which we use of, there is always a component of hidden layer in it. If we want to know what hidden layer is, these are the layers which are between the input layer and the output layer, which are the governing components which help us to get a better prediction of the output. So these hidden layers might be one, two, or numerous based upon the requirement and the kind of model you're building. And each hidden layer has its own different properties. Let's try to think about in terms of an example. So let's see if you have seen, if you want to identify a car in a picture using a neural network. And we use around 10 hidden layers. As mentioned earlier, each hidden layer has its own different function and different properties based upon the kind of information getting into it and kinds of the weights and bias assigned to it. So when we are trying to identify this car, one hidden layer might be able to identify what is the tire. The other hidden layer can be able to identify, let's say, a steering wheel, and so on. Each individual hidden layer cannot tell that this is a car because it does not take into account all the elements to tell us if this image has a car or not. So when we combine all these hidden layers, align them in such a way such that all the combined effort of the hidden layers can tell us that there is a car in the image or this image is a car. So this is how a hidden layer works and tries to develop any network, either being identifying an image or doing a time series analysis. Next, we talk about the other main components which govern how the prediction of the output would be. These are weights and bias. What does weight represent? Weights are the parameters which are assigned to the inputs such that they can convert this input to the desired output. Let's say we are giving 1 as input and we want 3 as output, just for the sake of an example. So what does this weights do? In the starting stage, when the 1 is given as input, the weights, let's say, assign multiplied by 1 and then give it to the hidden layer and pass it to the output layer. When going through this process, they know what the output should look like because we already provide them with an output to see how they need to convert. So during this process, while they are checking for the errors which we'll be defining in the network, if they find that 1 is not near to 3, which is the ideal output, they bring back the error to the feedback and give it to the weights such that these weights change themselves and try to get near to the output. So these weights are like multipliers or factors which change the input in such a way that it is near to the output. Each hidden layer might have different number of weights based upon different number of neurons it is connected with, and it might give different output for every run. Whereas bias are the elements which help us in getting the output as near to the desired as possible. Bias helps us by taking into the account about the output which we have, based upon the weights assigned to the inputs. So in this way, weights and bias work together such that they'll be able to give us a very good output. Once the data passes through the hidden layer, it comes to the output layer and it is represented as output at the end of the network. So this is what the general structure of a neural network is, and what each element of Narx neural network is, and how it is used for getting a desired output. To understand better, we can see a simple mathematical function which represents the basics about a Narx neural network. So we can see here f represents the function where y is the variable of our interest and u is an external input. So function of y of t minus 1, minus 2, minus 3 represents the past values. Similarly, u t minus 1, t minus 2, t minus 3 represents the past values of the external inputs. So to give the better result from the network, the Narx neural network takes into the account the past values of the variable of interest and also the past values of the external inputs, which is what x represents as exogenous inputs. So based on the values of past information of our variable and the external inputs, our network is trying to give a better prediction output. Just for an example, if we say y is the air temperature which we are of having interest in to predict, and u, the external inputs can be the day of the month of the year in which we are interested in. Because let's say if it's a summer, the temperature might be higher compared to the season of winter, right? So this is how the Narx neural network works and tries to develop a good model to give a good prediction. This is the total basic concept about Narx neural network and the various elements which are involved in it. In the next video, we will see how we can develop a code in MATLAB so that we can start using the concept we learned to apply it in real time. So that is it for this video. If you have understood the concept, give the video a like and subscribe to the channel. If you have any doubts regarding this concept or any other, just put your questions in the comments and I'll get back to you as soon as possible.